We will be looking at the slope of vertical and horizontal line segments. A horizontal line segment should be recognized as a relationship between variables where no vertical change exists. An example of a horizontal line can be found in example number 1. Find the slope of the line segment. Now, often in math, and I really like this about it, it is that it is made with a vocabulary that makes sense. Now, if I was to ask you, what is the slope of the line in example number 1? Well, you may not know what slope is, but if I change the question is, are we going uphill or downhill in example number 1? Well, you would say that we are going neither uphill nor downhill, or in other words, it's flat. And really, since the slope is the measurement of how steep or how flat a graph is, we can say that this has no slope to it. And in fact, numerically, that's what we'll find. Now, slope is equal to the vertical change divided by the horizontal change. Allow me to ask you, what is the vertical change, that is the change of y, in these two variables? Recall that slope is change of y over change of x. So the vertical change, well, it goes from 3 to 3. If we call this point A and this point B, ya minus yb. However, my horizontal change goes from 0 to 4. So what we get is 0 over negative 4, or 0. So the slope here is 0. There is no change. Now, example number 2, we're going to find the slope of a line segment with endpoints negative 2, negative 3, and 5, negative 3. So with a little bit of experience, we're able to say, well, I think that the slope is this. So I'm just going to make a quick sketch of my Cartesian plane. Now, this is a sketch. It is not a graph. It lacks all detail. But since I have a good nose for this stuff, I'm going to call this B. And B will have coordinates negative 2, negative 3. A is going to have coordinates 5, negative 3. So what I'm able to see is that there's going to be no slope here. But maybe if you don't see that, that's fine. But I'm going to find the slope. And slope is defined as slope is equal to ya minus yb divided by xa minus xb. And slope is going to be equal to ya is minus 3 minus 3, right? Yb was negative 3. Xa is going to be 5 minus negative 2. And what we get is my slope is going to be 0 over 7, or 0. So my slope is 0. Now recall that, for example 2, or generally in math, if you have any fraction where x is just a constant, maybe I should write that as k is constant, where k is some number, well, it's 0 over any other number is just going to be 0. There's a little math thing that maybe you already know. A vertical line segment should be recognized as the relationship between two variables where no horizontal change exists. So when we look at a vertical line, there it is. What are we saying? We're saying that horizontally, this does not change. So vertically, what is my vertical change? Well, what I can see is that my vertical change, I may want to write it as 3. My change of y is 3, because the way that I'm going to view this is I'm going to start there, and I'm going to work my way up to there. So it changes 1, 2, 3. The horizontal change is 0. So 3 over 0 is 3 divided by 0. Well, that is undefined. Now, a lot of people incorrectly believe that a constant like 3 divided by 0 is going to be 0. Well, in fact, it's not true. You cannot divide by 0. It is one of those rules in math that I have never seen in any circumstance somebody successfully divide by 0. It is one of those rules that is unbreakable, and there's really only about 2 rules that are unbreakable in math. So you cannot divide by 0. And by the way, what is this slope? We would say it's undefined. Now, allow me to give a practical example. You and I, we're going to climb a steep cliff, and it's straight up. How would you describe that slope? Well, how steep is it? In words, you would say, whoa, it's not steep. This is straight up. And that's because it has no slope. That is purely vertical. So your slope, in mathematics terms, would be undefined. All right. Example 4, find the slope of a line segment with endpoints at 3, -4 and 3, 5. Some of you may be able to look at this and say, aha, I know that this is going to have a slope that is undefined because there's no change in the x. Anyways, I'm just going to call this point A, this point B. My slope, I'm going to plug it into my formula because that's what it seems like I'm going towards. By the way, it doesn't matter which point you take as A and which point you take as B. It'll all be the same in the end. YA is going to be 5 minus YB, which is -4, divided by 3 minus 3. And what I get, it's going to be 9 divided by 0. So this implies that my slope is undefined. Now, we're almost done the video, but I am going to go over example 5. And just very basics from graphs. Always from graphs, we read from left to right. It's what we do. It's the standard way of reading a graph. When you get more advanced, maybe you can do something a little bit different. But for each of these, I'm going to read the graph left to right. For each line segment below, state whether the slope is positive. Now, positive, we call this increasing as well, but uphill, downhill, 0, zero or undefined. So really, uphill is not a math term. So if you put, oh, that slope is uphill, I'll mark it wrong. But that's the way to look at it. So here we are. We're going to read the graphs left to right. So I'm going to start with the leftmost point, and I'm going to go to the rightmost point. What we see here is that as I move left to right, that my slope is going down, so my slope must be negative. Now, what I see here as I move left to right, it doesn't really make sense to go left to right because it's just purely vertical. Vertical lines have a slope that is undefined. For C, as I move left to right, this is flat. The slope is 0. For D, as I move left to right, what do I see? I see that I'm going uphill. So again, left to right, I'm going uphill. So this implies that my slope is positive. And really, that's all there is to it. Always read a graph left to right.